and it is recording. So exercise 1E, we're going to get to know what a straight line equation looks like and what are things that you need to focus on. Previous exercise so far was helping you to build your algebra strength. So without the previous exercises, then when you start solving, that's where you run into issues. But this is the graph. This is the end goal. So y equals mx plus c right here, this is your general, we call this your general linear equation. So if they ever say, find the equation of a straight line, this is the first thing you should be thinking about, because every straight line falls under this type of equation. There are only two, what we call parameters, two parameters that you need to find. These are parameters, m and c, whereas x and y are called variables. So those are the things that you put in. X is what you put into the equation, and then y is the result that you get out of it. Parameters don't change for that particular equation. So here's an example. If I gave you a sample of a linear equation, let's say y equals to 3x minus 2, that is a particular straight line. So if I go to Desmos, I'll show you as an example so you can visualize what it looks like. Let's go to Desmos. If I go to Desmos and I type exactly what I just wrote, y equals 3x minus 2, that's one line. Okay, it's not two lines, not three lines. Well, to get this line, I needed an x coordinate and a y coordinate. So based on the pattern, you can see that when x is, say, 1, 3 times 1 is 3, and then 3 minus 2, that gives me 1. So that means there should be a point on the graph that is when x is 1, the y coordinate is 1. And you can see that it's shown here. Okay, so that's one example. So that's why these are called variables. When you put in an input, so x coordinate, you get a y coordinate that comes out from the equation. So m and c are your parameters. So for every single straight line, there is only one set parameter for that straight line. So for example, if I drew another straight line, I wrote y equals 2x minus 1. So I change the numbers, I get a separate line. Okay, so that's the difference between parameters and variables. So when you're solving for an equation of a straight line, all you need to find are the two parameters m and c. So let's start off. M stands for the gradient of a straight line. Now, out of curiosity, what you might have seen in year 8 if you did year 8 accelerated, what is the gradient by definition? What is that? It is rise over run. Is rise over run. What else do we know about the gradient? You else know? Rise and run. So if I drew, this is like your run. This is your rise. So the slant or the slope is what the gradient is. So how slopey the line is. The steeper it is, the higher the gradient. The flatter it is, the smaller the gradient. Right? What else? What else did you learn? Anything else that you know as a property of gradient besides rise and run?
A change in y is a change in x.
Whoa, that's special. So change in y, which we normally call delta y, delta x, which is why in year 11 we talk about calculus. That's where it's coming from. So learning your gradients links to calculus there. Change in y, change in x.
There's 4 types of gradients.
There are 4 types of gradients. That is true. So I'm going to write here 4 types of gradients. Positive, negative, 0, and undefined. Positive looks like this. Negative looks like this. So from left to right, it goes down. Positive is left to right, it goes up. 0 is a nice horizontal line. Whoops, I can't do a horizontal line there. And then undefined is a vertical line. I'll talk more about that soon, but I'm still looking for a formula, which links back to change in y and change in x.
y2 minus y1 over x2 minus x1.
Very good. This is the most common formula that you learn at the beginning of year 9 when you start doing linear equations. y2 minus y1, x2 minus x1 is the definition for what Andrea was saying before, that is change in y over change in x. Because what you're saying is, from one y coordinate moving to the next y coordinate, what's the difference? That's what you're looking for. Okay, so if you went from y coordinate 1 to y coordinate 10, how far have you moved? That's the change in y. So hence y2 minus y1. And then same thing with the horizontal line. It's how far you've gone horizontally. So if you've gone 10, you started at 10 and you end up at 20, well then what's the difference? So it's your initial and your final. So final minus initial tells you the difference. Okay, so hence the definition delta y, delta x. So these two, mainly, I'm going to highlight it. Rise over run is what they usually learn at year 8 mainstream and then year 9 mainstream. Year 9 mainstream adds in this for some students. I'm assuming you guys would have learned it last year. Then there's one at year 10, but I still teach it to my year 11 methods who may not have seen it in year 10. Just out of curiosity, anyone also know what else it could be equal to? So this is a bit theoretical, but it will make a lot of sense once you see the picture. Anyone else know? It involves an angle. All right, good. So I'll teach you something new. It's also equal to the tan of an angle. Now, if you remember back in maybe last year where you did SOHCAHTOA, what's tan of theta equal to again? TOA, which represents what? Yes. See, if you break this apart, opposite divided by adjacent, if you think about that right angle triangle I just drew, we said rise over run. That's a definition of a gradient, right? In a right angle triangle, if I drew the angle here, can you see the rise is actually your opposite side? And this is also your adjacent. Every time you have a slope, there has to be a horizontal distance and a vertical distance. That's why it's a triangle. So that's why tan of an angle, when you type on your calculator, tan of, say, 45 degrees, so if I do it on my calculator, which will take a while, but when you type tan of something on your calculator, whatever the number it splits out to you, what it's actually saying is it's the gradient. So for example, I'm just going to draw on a side here. If I said tan of 45 degrees, what you're actually saying to the calculator is this. You're saying if this is your x-axis and you created an angle of 45 degrees and that's the shape, what you're saying is the proportion of rise and run works out to be rise over run is equal to whatever that number is. Now I know tan of 45 is 1, so you're saying it's a gradient of 1, so it means it's a 1 by 1. But that's a bit sort of in depth. But for you to understand that tan, when you type tan, opposite of adjacent just meant rise over run. That's why tan theta is the same thing as a gradient.
If we were to chunk that in the calculator, we don't know the angle,
so the questions, if they do give it to you, they'll give you an angle. Or they might say find the angle. So if I told you that there is a line, say, you know that line that I gave to you guys before, 3x minus 2? What's the gradient at the moment? I'm tanging it off a bit. It's not 3x, it's 3. It's the number that's multiplied to the variable, yeah? So m is equal to 3. Now, we also know m is also equal to tan of an angle. So what you're saying is 3 is equal to tan theta because m is equal to tan theta and tan theta equals to 3. So if you want to know what the angle is, if you want to create a gradient of 3, you can actually do theta is equal to tan inverse of 3 on your calculator, and whatever angle it gives you, that is whatever. So I'm assuming for those who haven't seen SOHCAHTOA, you might be from the mainstream, so you might not have seen SOHCAHTOA before. Okay, then I might be pushing your boundaries at the moment.
What's the inverse thing?
That's the opposite of tan. So it's like opposite of add is subtract, opposite of times is divide, opposite of tan of an angle is the tan inverse. Forget about this. We'll get to trig later on. I might have been pushing it. Okay, I was just trying to see where you guys are roughly at. All right, ignore that and let's go back. Okay, so good news is you're not going to do the tan stuff. I don't think there'll be questions that we'll do with the tan stuff, but it's good to know. The next one, C. C represents your y-intercept, which I've got over here. Now, back in year 8, when you want to find the y-intercept, you let x equal to 0. And the reason for that is because if you pick any point on the y-axis, just think of any point on the y-axis at the moment, it always starts off with 0 and then whatever the y value is. Okay, and that's why we say if it's going to cross the y-axis, well, we know the x coordinate has to be 0. Okay, so visually, if I show you this graph, you see that y-axis is here, any point, doesn't matter which one you want to pick, if you picked it, it always has to start off with 0 and then 1. That's how I get a point on the y-axis. So every time you pick a point, that's why x is 0. That's why they say let x equal to 0. Okay? It's just a factual point. So note x-intercept, you let what? Y equal to 0 by the same theory. Okay? Same idea. Every coordinate on the x-axis, it will be x, and then y will be 0. That's why you let y equal to 0. Okay? Now, someone said before the types of gradients, it's already here, drawn for you. So negative goes down, positive goes up, 0 is horizontal, and undefined is vertical. Why is this true? Anyone know? Can anyone explain to me, why are we just memorizing it? What's the reason for it? No? What's the reason? Anyone know? So why is this called positive, negative, 0, undefined? Did I just name it, or is there a reason to it? Well, that's what I said to you, but there has to be a mathematical reasoning, right? That's exactly it. Very correct. What if you weren't sure what Violet was saying there, you know your formula that I gave to you just now? You can prove yourself by just picking 2 points. So if you wanted a horizontal line, right? So if we go back to this one. If I wanted a horizontal line, that's 0, 1. Let's pick another one over here. That's 1, 1. So if I pick 1, 1, that's a horizontal line, right? Now if I asked you to find the gradient, this is what you would have done. y2 minus y1, so 1 take away 1 on the top, 0. Then x2 minus x1, so 1 take away 0, which is 1. So if you put rise over run, rise is 0, divided by what you just calculated for x2 minus x1 is 1. Now what's 0 divided by 1? That's why we call that a 0 gradient. If you wanted to try, if I picked a positive gradient, right? So 1, 2, let's pick 1, 2. If I change that to 1, 2, and then I asked the same thing, I said, let's use your rise and run. What you would have done is, you would have said, rise, y2 minus y1, 2 minus 1 is 1, and then x2 minus x1 is 1. So 1 divided by 1 is positive 1. That's why we say it's a gradient of positive 1. Okay, that's why it's positive. If you do it the other way, it becomes negative. That's why there's the names. And if you think about the logic, that's why we call it undefined. When is it undefined? When it's vertical. Let's try it. If I picked out 0, 0, why is this undefined? Can someone explain it to me? What's the problem? Well, there is numbers. Not the numbers we're familiar with. Yeah, let me do it for you. Let's see why it's undefined. 0, 1, and 0, 0. This is x1, y1, x2, y2. 0, take away 1, 0, take away 0. Let's work it out. So y2 minus y1, x2 minus x1. I wrote it out. What is negative 1 divided by 0? What's negative 1 divided by 0? Type it on your calculator. Yeah, I'll show you. Let's try it. 1 divide 0. Okay, that's why it's undefined. Okay, so all of that you needed to memorize. Thanks, team. Whilst you're excited, it's great. Try to hold yourselves as I'm explaining it. So the logic to it is it's just based on the definition you were saying. The naming comes from the mathematics. So as you do the mathematics and you pick the points, whether it's down or up, you start to realize why they call it positive, negative, 0, and undefined.
How do you find which one's the first one?
Doesn't matter which one. You can pick either one and it will still be the same. Because when it comes to ratios, it doesn't matter, it's the proportion. That's why whether you take one or the other doesn't matter. when it comes to ratios and proportions. Doesn't matter which one you choose. Yeah. All right, team. Let's do an example together. Can you all flip over to the next page? Let's put all this in practice. Here we go. Flip over to the next page. We ready? So when you're sketching, there are two methods to learn how to sketch a straight line. So what I showed you on Desmos, they can sketch it for you. Eventually you have to learn to sketch it yourself. So there are two methods. There is gradient and intercept method, arguably the easiest way, but more tedious. X and Y intercept is the more preferred method, but it does require that you know your algebra. So assuming that you've done exercise 1A, B, then you have a general idea of how to solve to be able to sketch. So I would say that this is what I generally look for from students. This is, as a beginner, that's when I teach to just read the equation. So let's practice reading the equation. So I told you there's M, which is the gradient, and C is the y-intercept, right? So here, let's read. What is my M equal to in this equation? 4, very good. So 4 is my gradient. And then my y-intercept, which is? 3. So I'm going to write here, this is your y-intercept. Now, when you say gradient, we said it was rise over run. It's a fraction. It's a proportion. What's 4 as a proportion or a fraction? 4 over 1. So what this means is you will be rising by 4 and you're running by 1. So horizontally, you're moving 1 unit, and then vertically, you're moving 4 units. So how do you sketch? If you can read it, then you can sketch it. This is how you sketch. You find the y-intercept. You already told me the y-intercept was at 3. So here's my y-axis. 1, 2, 3. So my first point must be right here. This is 0, 3. So you got 1 point. Now, how many points do you need to sketch a straight line? 2. So to get another one, you just follow what the gradient says. The gradient says run 1 and then rise up by 4. So if I follow that, let's do it. Run 1, so I go across 1, up by 4. 1, 2, 3, 4. Where would that lead me up to? If I went up by 4. So remember, the y-intercept is at 3. If I went up by 4, I should be at? 7. So that means this point up here is 7, but I went across 1, so it should be 1, 7. You see what I've done? So I just went 0, went across by 1, and then from that point I went up by 4. So if I draw it out, so this is 4 units up, 1 unit across. That's what a gradient means. It's 1 across, 4 up, 1 across, 4 up, 1 across, 4 up. That's my ratio. So now that you got your 2 points, grab out a ruler, don't do it by hand. If I see that there's any curves in it, you didn't use a straight line or a straight ruler, I'll penalize you. So it should be like that. And that's sketching. If you don't have a ruler, you can fold a piece of paper in half and you use the corner side. That's why I teach my Year 12s. So far, so good? Copy it down. All right. Let's try the next example. Next example. So what happens when you get an equation that isn't in the form of a general linear equation? So we're used to saying y equals mx plus c. It means that you need y by itself, and you have to move all the x's and all the other numbers on one side so that you can tell which one's your gradient and what's your y-intercept. The problem with this one is that you've got x and y's on the same side, so you need to rearrange it. So here, how do we rearrange it? Good. So you got 2x minus 4y. There's a lot of ways to do this, by the way. I personally don't like the negative 4y, so I probably would have done the same. I would have just said add 4y on both sides. Sorry, where's my pen? Here we go. Add. Why do I add? Because that's minus 4y. So add 4y on one side, add 4y on the other side. These cancel out because negative 4y plus 4y is 0. Then what do you end up with? Well, you end up with 2x left over is equal to 8 plus 4y. But remember, I've got rid of the x, but I don't want that 8 next to the y. We need y by itself. You minus the 8. So here we then say minus 8 on one side, minus 8 on the other. 8 take away 8 cancels out. And I will now have 2x minus 8 is equal to 4y. You can't combine those because they're not like terms. And then finally, to get y by itself, I don't want the 4. How do I get rid of this 4? Divide by 4, very good. Divide by 4, divide this by 4, divide this by 4. So remember the number of terms? I taught you how to count terms. There are 2 terms here. So when you divide it by 4, you need to divide each term by 4. And this now cancels out. And it gives you, therefore, y is equal to 2 over 4 is the same thing as half. X, 8 over 4 is the same thing as 2, so minus 2. So from that, what's my y-intercept? What's my gradient? What's m and what's c? 1 over 2 is my m. And then c is negative 2. So what that means is y-intercept is at negative 2. And your rise is 1. Your run is 2. So if you were just reading it, you can plot it now. You can say c is at negative 2. So find negative 2. Here we go. 0, negative 2. You got 1 point. You need 2 points to sketch a straight line. Follow the gradient. It says go up by 1 and then go to the right by 2. So here we go. Up by 1 to the right by 2. That gives me this point now. And that's 2, negative 1. You see that? So I went up by 1 and then to the right by 2. I just followed the gradient. Now you have 2 points. Use a ruler and sketch. So this is at the preliminary stages when they first learn straight lines. You learn the skill. It's only in year 9. At year 10, yeah, they still teach it, but then by the time you get to year 11, we don't use that technique anymore because it takes too long. Yeah, it would have been easy if we just found the x and y-intercepts before, and you would have been able to sketch the graph. All right? Okay, so this is a good entry method if you aren't strong with your algebra, x-intercept, y-intercept. Let's do the last example, and then I'll stop there. Did I do something wrong? No? Is it good? Good? All right. Here's the last example. Again, all these notes are on OneNote, so if I'm going a bit too fast, you can always go back and then watch my videos as well, okay? Here's the last one, and I'm going to stop here because that's 3 examples already. It's quite overloading. So we'll start here. X and y-intercept. So again, you said you only need 2 points to sketch a straight line. So if you can find your x-intercept and you can find your y-intercept, those are 2 points that you can sketch. Now, you copied the theory before on the first page. We said x-intercept, you let y equal 0. Whereas y-intercept, let x equal to 0. But the benefit is right now, I already know what my y-intercept is. C, which is my y-intercept, which is? Negative 6. So you already know 0, negative 6 is one of the points, so you don't have to do any algebra. But the x-intercept, you know that y needs to be 0. So in the equation, y equals 2x minus 6, you're going to substitute y is equal to 0. 0 equals 2x minus 6. Your job is to solve x. Now you did this back in year 7 when you first learned inverse operations. So from here, add 6 on both sides because that's a minus 6. 6 take away 6. Cancels out. You then have 6 is equal to 2x. And because 2x means 2 times x, to get rid of the times 2, we divide both sides by 2. 2 divided by 2 cancels out to be 1. That's why you're left with x. And then finally your answer is 6 divided by 2, 3. So that tells me your x-intercept is at 3. X is 3 and y is 0. Because you sub y is equal to 0. You said the y corner has to be 0. And that's it. Plot the 2 points. 3 zeros over here. That's your x-intercept. 3, 0. Make sure to label the coordinates. At the senior level, if you don't label in coordinates, you lose marks because the questions are always saying label your axis intercepts in coordinates. So if you don't do that, you'll lose a mark. And then your last one is 0, negative 6. So your y-axis, 0, negative 6, that's 1, 2, 3, 4, 5, 6. So here we go. That's my point at 0, negative 6. And then you finish off your equation. Make sure to use a ruler or something straight. And you're done. So out of the two methods, one requires algebra. The other one you just read. You're practicing this sketch a straight line equation. Have a go. That's your exercise 1E. I'm going to write the solutions for the next one. And you can have a look if you like, or have a go. I'm going to stop the video there.